In triangle RST, point Q is the centroid, and VQ equals 5. Find RQ and RV. The centroid is 2/3 of the distance from each vertex to the midpoint of the opposite side. So VQ equals 1/3 times RV. Substituting in 5 for VQ gives 5 equals 1/3 times RV. Multiplying by 3 on each side gives 15 equals RV. And RQ equals RV minus VQ. Substituting 15 for RV and 5 for VQ gives 15 minus 5, which equals 10. So RV equals 15 and RQ equals 10. Find Find the coordinates of the centroid of triangle ABC with vertices A 0, 4, B -4, -2, and C 7, 1. Begin by graphing your triangle. Start with the vertices A 0, 4, B -4, -2, and C 7, 1. Connect the points using line segments. Then you need to use the midpoint formula to find the midpoint M of line segment AB and sketch the median MC. So the midpoint M of line segment AB is 0 minus 4 divided by 2, 4 minus 2 divided by 2, which is -2, 1. Graph your midpoint M, -2, 1, and sketch the median line segment MC. The distance from M -2, 1 to C 7, 1 is 9 units, because 7 minus -2 is 9. So the centroid is 2/3 times 9, which equals 6 units to the left from point C on line segment MC. So you can start at point C and count 6 units to the left, or subtract 6 from 7, which gives you the point 1, 1. So the coordinates of the centroid are 1, 1. Find the coordinates of the orthocenter of triangle DEF with vertices D 0, 6, E -4, -2, and F 4, 6. Begin by graphing your triangle. Start with the vertices D 0, 6, E -4, -2, and F 4, 6. Then connect the points using line segments. First, find an equation from the point D to line segment FE that contains the altitude. So the slope of line segment FE is 6 minus -2 divided by 4 minus -4, which equals 8 divided by 8, which equals 1. So the slope of the perpendicular line is -1. Then use the slope-intercept form to find the equation of your line. Substitute in the point 0, 6 and your slope -1, which gives 6 equals -1 times 0 plus b. Simplifying gives 6 equals b. So the equation of your line is y equals -x plus 6. Graph this line on the coordinate plane. Notice that your line goes through the point D06 and is perpendicular to the line segment FE. Next, find an equation of the line that contains the altitude from point E to line segment DF. Because line segment DF is horizontal, the altitude is vertical. So the equation of the line is x equals -4. Because x equals -4 goes through the point E -4, -2. Graph this line on the coordinate plane. When x equals -4, y equals -4 plus 6, which equals 4 plus 6, which equals 10. So the point -4, 10 is the intersection point of these two lines. So the coordinates of the orthocenter are -4, 10. Prove that the bisector of the vertex angle of an isosceles triangle is an altitude. Given that triangle ABC is isosceles, and line segment BD bisects angle ABC, prove that line segment BD is an altitude of triangle ABC. Line segment AB is congruent to line segment BC, and angle ABD is congruent to angle CBD by definition of angle bisector, and this was given information. And line segment BD is congruent to line segment BD by the reflexive property of congruence. So triangle ABD is congruent to triangle CBD by the SAS congruence theorem, because you have corresponding sides, angles, and sides that are congruent in the corresponding triangles. Then angle ADB is congruent to angle CDB, and they form a linear pair. These two angles are congruent because corresponding parts of congruent triangles are congruent. Then line segment BD and line segment AC intersect to form a linear pair of congruent angles. So line segment BD is perpendicular to line segment AC, and line segment BD is an altitude of triangle ABC.